everyone, my name is Ahmed and I welcome you to my YouTube channel. This channel is specially designed for electrical engineering students and for anyone interested in technical knowledge. Here you will find simple explanations of concept, practical example, and MCQs to strengthen your understanding. Don't forget to subscribe to my channel and like the video because many more interesting and helpful lectures are coming very soon. Stay tuned and keep learning. Thank you. So now we will start slide by slide explanation of the Ohm law. Ohm law is one of the most important and basic rule in electrical engineering. It is it explains the relation between the three key quantities: voltage, current, and resistance. So this is the voltage, current, and resistance, and this is the three parameters of the electric circuit. So inshallah we will discuss one by one. And according to the Ohm law, voltage is equal to the current multiplied by resistance. If the voltage increase, the current also increase, provide the resistance remain the same. If the resistance increase, the current decrease for the same voltage. So we can also write, by using this law, we can easily calculate the current, voltage, resistance in the AC circuit. So as you are looking here, Ohm law formula. So this is the uh, simple formula in this image. If you, for example, if you want the current, so this is the current. So the current, the two variable will be find before, like voltage and resistance. So these are the both variable, voltage and resistance will be find before. So then you will get the current. Uh, if you find the voltage, so voltage is equal to current and resistance. As you say in this snap picture, if you find the R, so you have to find first voltage, then current. First you have to find the voltage quantity, then the current quantity. Differently, then you will get the resistance. This is also the simple definition of the Ohm law. So from here you can also see the amount of current is proportion to the voltage applied to the current and inversely proportion to the resistance of the circuit. This is example of the Ohm law numerical. So the voltage and resistance are given. Voltage is 20 volt and resistance is a 5. 20 volt and resistance is a 5 ohm. So I is not here. So first we will find the I current. Current is equal to V by R. So the current value is 4 ampere. Then you can find then you can find the current value. So this is a simple circuit. We can easily understand from this. And this is the generic definition. Like Ohm law formula. V is equal to I. So if you find the voltage, so first you have to find the current and then resistance. Voltage across the ends of the conductor. In current flowing through the conductors. Resistance offered by the conductor. Now we will go to the advanced concept. So the advanced concept is like that the presentation explore the fundamental of Ohm law, focusing on definition of the core element of voltage and current in resistance. So we will look at how resistance changes with temperature and highlight the cases where the material do not follow ohmic behavior. This discussion also covered the use of the Ohm law in the alternator current, supported by clear graphical representation to enhance the comprehension. Advanced modeling tools and visual example will be applied throughout. So now we will go on the second slide. So this is very simple that we have discussed before in the first slide. So definition of the Ohm law. Ohm law is a fundamental principle in electrical engineering that describes the relation between the voltage and current and resistance and ohmic material by understanding this law, one can effectively analyze and design electrical circuit. Ohm law explanations. The electric current through the conductor is directly proportional to the voltage across it. The second is mathematical expression. How we can the mathematically expression express is voltage is equal to current and resistance for the ohmic material under the constant conditions. So this is very simple. This the both are the generic definition. Importance of understanding fundamental for analyzing electrical circuit and components. So now we will discuss about the key variable in electric circuit. So there are three variable in the electric circuit. The first is voltage, the second is current and resistance. So we the people can see here voltage measure in volt. It is the potential difference that cause the current to the flow through the circuit. So this is voltage. So the voltage. So this is the voltage like we find V is equal to, this is the first variable I naught. The second variable is current. Measure in ampere, it represents the flow of electric charge in the current. So this is the current. So we can, if you find the current, so first you have to find voltage, then resistance. Okay. The third one is the resistance. So resistance is equal to V divided by I. Sorry, I. So first you have to find voltage, the current, then you can get the resistance. Now we will go to the next slides. is so in this slide we will discuss about the advanced modeling temperature dependence. So Ohm law works perfectly for many situations, but in the real life, the resistance of material change with the temperature. So formula like the temperature resistance, we can we can write that that R and T is equal to R naught 1 plus delta T. So if you have to find the temperature resistance, so you can write this. So RT is resistance at temperature. In RO, you can consider that RO is resistance at the reference temperature, usually 20 centigrades. In alpha, this is the alpha. So the alpha will be considered temperature coefficients of resistance per centigrade. Okay. So the delta T we can we can write like that delta T is equal to 1 is equal to T minus T naught T naught. It's mean the change in the temperature. Okay. This means that for the metal, resistance increase as temperature rise. For the semiconductor, resistance usually decrease a temperature rise. So in the advanced model, we can't treat the resistance as a constant. We must include the effect of temperature, especially in the high power precision circuit. So this is the simple advanced modeling temperature dependence. Hmm. Now we will go to the next slide. In this slide, we will discuss about the non-ohmic behavior in electronics. So, as you see that we have discussed in the previous slide, the Ohm law said that the current is directly proportional to voltage provided the resistance remain constant. But in the reality, many electronic devices do not follow the Ohm law. These are called non-ohmic devices. So, non-ohmic material devices, uh, voltage and current graph is not straight line. That's why the resistance is not constant. It changes with the applied voltage, current, and temperature. So, the example of non-ohmic devices, you can say diode. So, the diode, this is the one non-ohmic behavior, and the second one is transistor, transistor. And this is visible. There is very uh, easily visible. The filaments is also, the lamp is also in semiconductor like diode and transistor. Okay. The next slide, extension to the AC circuit. In this slide, we will discuss about extension to AC circuit. What is the first one is impedance definition, AC Ohm law, component rules. So we knows very well that in DC circuit Ohm law is written as V V is equal to I R. So, but in the AC circuit, we also have to consider the effect of inductance and capacitance along with the resistance. So, these elements like capacitance along with the resistance causes a phase difference between the voltage and current. So, in AC, we use the concept of impedance instead of simple resistance. V is equal to like V is equal to I multiply by Z. Okay, if we find the Z, so Z will be is equal to R square plus X square under root R square plus X square. So then you will get the Z value. The same is inductive reactance, capacitive reactance. XL is equal to 2 phi FL, and capacitive reactance XC is equal to 1 by 2 pi FC. So this is the simple extensions to the AC circuit where we can get the Z value and we can get the V value. Next slide. So in this slide we will discuss about the graphical representation of ohmic material. So the first one is linear relationship. The second one is slope is the resistance in engineering applications. So in this slide, graphical representation of the ohmic material. So we can say like that ohmic. So ohmic material follow the Ohm law, meaning current is directly proportional to applied voltage when temperature and other physical conditions remain constant. So this is the graphical representations of ohmic material. So we can write it like that. X So this axis on axis will be voltage, and y axis will be current. X axis will be voltage and y axis will be current. Now we will discuss about a little bit about the slope in resistance. So for ohmic conductor like met- metallic resistance, the graphic is a straight line passing through the origin. The slope of the line depend on the resistance. Like we can say the simple I is equal to V by R. A similar slope is equal to the higher resistance, and steeper slope is equal to the lower resistance. So the next slide will be, this is the last one slides, and this is the generic definition of Ohm law. Understanding electric concept that we have discussed uh, in the first and two slides, that Ohm law, this is the simple V is equal to IR explain ohmic material behavior, resistance factor, temperature impact resistance in the various material, impedance in this circuit. The impedance include more complexity behind the resistance, and the graphical representative visual help differentiate device type the analysis. So this is the end slide, and all right, this is the end today lecture. I hope you have understand the concept we discussed and gained some useful knowledge from it. If you have any question or suggestion, feel free and comments below. I will be happy to respond. Don't forget to like the video and subscribe to my channel because more helpful lectures are coming soon for all electrical and technical students. Thank you for watching and see you in the next video.